So let's look at a few of these. The first one, let's start from the very simple one, maybe. Okay, so the first thing is, let's look at this one, and then I'm going to move there. So can you tell me what is this going to look like? Which kind of bond is this? What kind of bond is this? Ionic, polar covalent, or non-polar covalent? So it's silicon and hydrogen. So what do? I'm going to go back to silicon and hydrogen. So silicon and hydrogen, what kind of bonding do you think it is? Silicon is here, and hydrogen is over here.
Ionic.
What is the difference between the electronegativity? What's the difference in electronegativity? 2.1 minus 1.8.
Is it non-polar covalent bond?
Uh-huh. Okay. And so when you look at that, even though the formula, it is, where do you go? Okay. Even though the formula is SiH4, doesn't matter, there are 4 hydrogen. You are not going to add 2.1. You're not going to do 2.1 times 4 because there are 4 hydrogen. You don't do that. It's just like you are looking at the bonding between silicon and hydrogen. So 2.1 doesn't matter how many are there. It's between 2.1 and 1.8, and the difference is 0.3. So you're going to look at this and say whether it's ionic covalent or polar covalent or non-polar covalent. Okay. The same for, like, here you have 2, so it's the same thing. Fluor, you're going to just look at the difference between electronegative with this and electronegative with this and find the difference, and that's and then going to look at which one do you think, where, and then check the table and see where it lies. Is it less than 1.4, then we say non-polar covalent, more than 0.5 or more, then we say it's not polar covalent, and if it's 1.5 or more, then we say, 1.9 or more, and then we say it is ionic bond. So let's do one of these. Let's do, so these are the single bonds. We're going to do this, and then we're going to move on to the double bond. So which one, if you have tried any of these, and if you are like, want me to do a special one of these, let me know. Otherwise, I'm just going to pick one and do it. Anybody has any preference of which one you want me to do?
Can you do G?
A, B, C, G. Okay. So G. So let's do G. So the first thing is to find out how many valence electrons are here. So how many valence electrons nitrogen has. Okay, and then we're going to do CH2Cl2. second time, okay? We'll do that. So how many? For nitrogen, there are 5. So 5, and there are 2 nitrogen atoms, so 5 times 2, and hydrogen has 1 times 4. So the total is 10 plus 4 is equal to 14. Am I doing it correctly or not? Let me know, because sometimes I also make mistakes. Sometimes I write 2 here instead of 1, and then at the end, and then when I could not figure out, when something didn't go right, and I have to go back and say, oh, I put the wrong number. So I think I'm doing good here, right? This is 14. So hydrogen always goes outside. So because nitrogen, so we can put the nitrogen, let's look at it. Nitrogen is, so nitrogen is in the middle, because you know that hydrogen always is going to stay in the outer circle. So we're going to put nitrogen here, and you have hydrogen. So we're going to divide those hydrogens on either side. 1 hydrogen here, 1 hydrogen here. And then you know that the nitrogen, if you go down here, what do you know? The nitrogen cannot have more than 3. It's typically it can have 3 bonds. And why is it? Can you tell me why is it? It is because if you go back over here and look at the periodic table, it's because nitrogen already has 5 electrons, and it can take, at most, it can take 3 more electrons. That is why we have nitrogen and phosphorus can have 3 bonds, typically 3 bonds, because it cannot take more than, it has to have 3 in order to have octet. Similarly, oxygen, sulfur, cerium, they can have 2 bonds, because let's look back. Oxygen, sulfur, how many do they need to fill their outermost orbitals? They have 6, so they need 2 more. 6, so they need 2 more. And similarly, if you go to nitric, fluorine, chlorine, bromine, iodine, and hydrogen, they only need 1 more electron. Hydrogen needs 1 more electron to have their outermost or the valence shell full. So that's why you see these here. And when you look at this 17, 16, 15, 14, you should also know, okay, that's because of that. Because carbon has, 4 electrons, so it can have 4 more electrons. Make sense? So that's why you see those numbers. So nitrogen can have up to 3. So 1, 2, and there is 1 nitrogen. We can put hydrogen here and hydrogen here. Now we have 14 electrons. The first thing is you're going to put those electrons in the outermost, the atoms that are outermost. The first, we're going to give each one a single bond, and then put the remaining one in the outer atom. So let's put a single bond. And instead of single bond, if you put just a dot for right now, will not be confusing for you. So I'm just going to put dots so that I can count the dots, okay? And I'm going to write a straight line later, because otherwise I'll be confused. So that's what I'm going to do. And I'm going to put 1 and 1 over here. So these all represents 1 bond, 1 bond, 1, 1, and 1. So how many electrons are used up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now the next step is for me to subtract that. I have 4 electrons left. Now I need to check whether, the first thing is I need to fill all the atoms which are in the outer circle. That's what I need to fill the electrons with. And if they are full, if their outermost orbital is full, then only I'm going to put those electrons in the atoms which are in the inner side. So let's look at hydrogen has 2. It's full, we know it's full. This is full, this is full, and this is full, which means these electrons, I don't have to put those in the outer circles. Now I have 4. Let's count. The nitrogen has 1, 2, 3, 4, 5, 6. This nitrogen has 1, 2, 3, 4, 5, 6. So I have 4 electrons. So what do I do? 1, 2, 3, 4, 5, 6. This needs 2 more electrons. So after I put 2 electrons, let's count. It has now 1, 2, 3, 4, 5, 6, 7. It does not need any more. So minus 2 electrons. So we have 2 more electrons left. So we're going to put 2 over here because it also needs. Now I've used all the electrons. I have 0 electrons left. Now I have to make sure the octet is complete or not. 1, 2 for the nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So its octet is complete. And for this also, it is complete. Okay? So then that means all of these atoms, they obeyed their octet rule. So it's all, so my drawing is complete. And one more thing that you need to check is, did we use all of these or not? 14 electrons. And let's count, because we said 0 here, but just wanted to make cross check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So all 14 electrons are used. So our structure is correct. Any question? So I'm going to erase this, and let's do the other one, CH2 and L2. So this is the one, so CH2. So carbon, how many electrons are there in carbon? How many valence electrons? 4. Hydrogen has 1 times 2, and chlorine has 7. 7 times 2. So what's the total is 4 plus 2 plus 14 is equal to 20 electrons. Is that right? Yes, okay. So we're going to put carbon in the middle. And we know that hydrogen cannot be in the middle. Similarly, chlorine cannot be in the middle. And we know carbon needs 4 bonds. So we're going to put 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, and 1, oops, I don't need it here. And then 2 hydrogen, and I'm going to put 1 chlorine here and 1 chlorine here. Now I'm going to start with 2 electrons. Okay, now I use 1, 2, 3, 4, 5, 6, 7, 8 electrons are used. So I have 12 electrons remaining. Now I'm going to look at these and see which one of these needs the electrons. So this one is full. Hydrogen does not need does not need. Now the chlorine has 1 and 2, 1 and 2. That means those chlorine needs. I'm going to start with any one of these chlorine. So there are 12 electrons. This chlorine has 2 to have complete octet. That it needs 1, 2, 3, 4, 5, 6, and 7 and 8. So I used 6 electrons. Now I have 6 left. 1, 2, 3, 4, 5, and 6. Now it's 0. Now let's count. When I count, what do I see is this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. It's complete. This has 8. It's complete. Now let's look at the carbon. This carbon has 1, 2, 3, 4, 5, 6, 7, 8. It's all. So, and then let's count whether the total number of electrons are 20 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So our structure is correct. So what is the last step to do is to write carbon, hydrogen, hydrogen, and you have chlorine here and chlorine here, but those chlorine has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So these are the lone pairs that needs to be there when you write the structure. Earlier when we did this one, we forgot to go to that step. For that also you need to do the same thing. And then in that case, you will have nitrogen in nitrogen, hydrogen, hydrogen, right? With a lone pair on either side. And we forgot this part earlier. Any question here? Okay, if it do not, then let's move on to the next one. So now we're going to do this. So do you have any preference of which you want me to do? If you have already done, and then if you are a little bit confused, I'm going to just do that. Otherwise, I'm just going to pick whichever I want. Any specific you want me to do? No? Are you guys here?
Can you do D or F?
D or F? D or F? Okay, so let's do, so are you guys following me? Are you getting it or not?
Yes.
Okay, thank you. So D, let's do D. Okay, D. So carbon, for the, how many, so the carbon has, as we said, it has 4, right? 4, and then we have 2 carbon, so 2 plus how many hydrogen? 1 plus 2. So 4 times 2 is 8 plus 2. So the total is 10. So 10 electrons, so 10 valence electrons. And these are carbon-carbon, so we put carbon in the middle and hydrogen here, hydrogen, and oops, it's 2 hydrogens. There are only 2 hydrogens, so we're going to put one on the either side. Okay, I'm going to start with giving them just 1 bond. Now I'm going to count. I used 6 electrons. So minus 6 electrons. Now I have 4 electrons left. And when I look at the outer circle, the hydrogen is full, it does not need, and this hydrogen is full, it does not need. But when I look at carbon, carbon has 1 and 2. This carbon has 1 and 2. So what do we do then?
Would it go on the inside carbons?
Yeah, so that's the next step. So this carbon has not 2, 1, 2, 3, 4. This is 4. See, this carbon has 4, and then that carbon has also 4 here. So they need 4 more.
Would it create a triple bond between the 2 carbon?
Yeah, we'll finally come there. But what I want to do is I just want to go step by step and learn step by step first. And then once you know all the what's going on there, then you can skip the step. Okay? For like few times, just go stepwise. And then once you know that, then you say, oh, I can skip that step and then just move on. And then you can do however you want to later. But just for when you are learning, so that you are not making any mistake, just go step by step. So that's what we're going to do. And then after that, you can do however you want to because you need the structure at the end. So 4 electrons over here. So the hydrogen comes, so we're going to go to the inner one. So let's start from the carbon. 1, 2, 3, 4. So carbon needs 4 more to be 8. So 1, 2, 3, 4. And now the number of electrons are 0. So we do not have anything now. It's all gone. So now let's count hydrogen and hydrogen. It's full, complete. When you look at this carbon, it has 1, 2, 3, 4, 5, 6. This is complete. But when you look at this one, it has got only 4. So this is not complete. So what happens is this carbon is going to share its 2 electrons. Now, this carbon has 1, 2, 3, 4, 5, and 6. Still not enough. So it's going to share 2 more electrons. Now, when it shares, now it has 1, 2, 3, 4, 5, 6, and 7 and 8. Finally, the outer, its valence shell is full. So when it's sharing, what it means, like you have an eraser, and both of you and your classmate who is next to you, both of you are using a pencil, and your friend doesn't have eraser, so you just put the eraser in the middle, or just say like, okay, you can also use it. I will use it, and if you want, you can use it. So that's the same thing. As electron, but it's sharing, so both of those can use it. So at the end, what do you get? Carbon and 1, 2, and 3 carbon, and so there is no lone pair, so no need to show the lone pair. Any question? So do you want me to do any over here? If not, I'm going to move on to the iron one. Anything here you want me to do? No, okay. So let's do this one then, one more last one, okay? So carbon has 4, hydrogen with 2 times 1 times 2, let's do 1 times 2. 1 times 2, and oxygen 6. So the total is 12 electrons. So the carbon in the middle and hydrogen on the sides over here, one hydrogen, you have oxygen over here. And as usual, you have 12 electrons. So we're going to start with 1, 2, 3, 4, 5, and 6. So minus 6 electrons, you have 6 electrons left, and you're going to check all of these. The hydrogen is complete, no need to worry. So oxygen has 1, 2. It needs 6 more. So all of those 6, we will be using it over here. Now, we do not have any. So the oxygen is good, hydrogen good, but this carbon has 2 less electrons. So this oxygen is going to share 2 more, and now it's complete. So then we will have hydrogen with oxygen with 2 lone pairs of electron. Okay, so let's move on to the last one, which is this one. Let's do this one, the last one over here. So in this case, it has 1 negative charge here. So we have total of carbon 4, hydrogen 1 times 3, this carbon 4, and oxygen 6 times 2, which is equal to 4 plus 3 plus 4 plus 12. So 20 and 23. It's 23 electrons, right? So there are 23, but we have 1 negative charge, so we will add 1 electron. So we have total of 24 electrons. And how do you do if it's like this kind of little bit complex compound, meaning like there are more types of atoms there? So we're going to write the carbon first, and then you know that this carbon has 3 hydrogen because these hydrogens are attached to this carbon. So we're going to put 1 hydrogen, 1 hydrogen, and 1 hydrogen. And there's another carbon here, and the oxygen is attached to this carbon. So we're going to write oxygen over here. Okay, now the next step is to give the electrons.
Would it be 2 oxygens since there's 2 of them?
Oh, yeah, 1 here and 1 here. Thank you. So now, after this, we're going to just count how many did we use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we used 12 electrons. We have 12 left. Now the hydrogen is complete. You don't need to worry about it. And then the carbon in the middle, we're going to look at it at the end. Now, first, we're going to make sure the outer one has full, its valence shell is full. This has 2, so this needs 6 more. This is complete. We used 6, and now we have 6. Now, this has 2, so it needs 6 more. So minus, it's 0. Now we're going to count. This oxygen has 1, 2, 3, 4. It has 8. This has 8. But when you look at carbon, it has 1, 2, 3, 4, 5, 6 only. Okay. Now in this case, the carbon can get electron either from this oxygen or from this oxygen. If it gets the electron from this one, then we will have what kind of shape? Let's make, then it will have 8 carbon, then we will have H, C, H, and H, and C, O, and double bond over here, and all with 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and you do need to put the negative charge over here. And if it gets the electron from here and not from there, then what will happen? Then we will have the structure one, two, three, four. So either it can be like this or it can be like this. So these two are the resonance, right? So this is called the resonance. This can have like this kind of structure or this kind. So the structure, actual structure is in between these two. It's the hybrid of those. Okay, so the last one that I want to show you is, so when you clear this, the one which is over here. So the same thing here, the process and everything same, the same process, only the thing difference is this has positive charge. So nitrogen is with 5 and hydrogen here 1 times 4. The total you have is 9 electron you have, and because it is positive charge, so we need to take out 1 electron, so it will end up with 8 electrons.